So in this part of the video, we're gonna graph this function x times x minus 1 times x plus 2 squared. So first we're gonna apply the leading term test. That is just finding the end behavior. So for the leading term test, what we're going to do is get all the x's and our leading term with the exponent. So x from here, and then x from the second one, and then x squared because it has a square right there. So when we multiply x times x times x squared, that would become x to the fourth. So leading degree is 4, and there's nothing in front except for an invisible 1. So the leading coefficient is positive. So positive 1 in the front, even exponent. So now we have leading degree of 4, so it's even and it's positive. So that means the end behavior for left and right side. So the limit of f of x. So say I do the left side, so x approaches negative infinity, that will equal to infinity. And then limit of f of x. Now the right side, so x approach to infinity, will also equal to infinity. So this information I got from the chart I memorized from the first video, 2.2a. So here's the end behavior. Now we're going to do zeros and multiplicity. So we're going to set each factors x, x minus 1, x plus 2 equal to 0. So x equal 0. There's nothing I could do. So this one, multiplicity of 1. Now let me do x minus 1 equal to 0. Solve for it. So x equal to 1. And it's only one time, so multiplicity of also 1. Now x plus 2 equal to 0. Solve for x. So we get x equal negative 2 with multiplicity of, so it's powered by 2, so multiplicity of 2. So now we're going to use this information, the end behaviors, the zeros, x equals 0, x equals 1, x equals negative 2, or also known as solution, to graph. So let me write out this information. So let's see. So the limit of f of x going on the left side is infinity, and then the limit f of x on the right side also equal to infinity. And then our solution now here I'm writing 1, that means multiplicity of 1. Here multiplicity of 2. Alright. So with this information, I'm going to use the y-axis and the x-axis in the middle. So now the end behaviors is telling me on the left side it's going to start up from here, and then also it's going to end on the right side up here too, because going to positive infinity. Now let's figure out our points. Alright, so at x equals 0, and then 1, and then -2 right here. So actually, let me make it wider so it's easy to see. So this is 0, and say that this is 1, and then this is -2. So I'm going to write 1 here, and then -2. Now this is the part where we have to look at the type of graph when it comes to these zeros here. So over here, say I'm going to write crosses, x-axis, crosses, x-axis, because it's an odd multiplicity. Now here it's an even, so it's going to be tangent on x-axis, so tangent. So even multiplicity, tangent, odd, crosses. So what happens is, so on the left side it's positive infinity, so it's going to be here, and then on the right side it's going to end here. So you can start anywhere you like. I'm just draw my arrow, so I can do like this. And what I'm going to do is I'm going to go through all the points that we have on the graph. So at -2, it's tangent. So I'm going to go towards it, touch it, but not go through it. Not going to cross the x-axis. I go up. No, doesn't have to be perfect. Go anywhere. Next is 0, so I'm going to cross it. So I'm going to cross it like this. And then 1. So I have to cross it, so I'm going back up. Like that. And then going back up. So again, it doesn't have to be perfect as long as you follow all these conditions. So on the left side it's infinity, which is true. On the right side it's also going to infinity. That's what happens when you have an even function. At 0 it crosses the x-axis, at 1 also crosses, and at 2 it's tangent. So again, it doesn't have to be a perfect graph. And then here, let me show you what the graph actually looks like. So both ends are going up just like my graph. It's tangent at -2. It crosses at 0, and then it crosses at 1. So again, as long as the graph looks similar to what I have, it doesn't have to be perfect, you can still get full credit. Write out the information, get partial credit. Again, this doesn't have to look like exactly. This does not have to exactly look like this. Just close to it. Yes, you are bitter, Vanessa.
No.
Alright, so in this example, or second example, we have f of x equals -x squared times x minus 1 squared times x plus 2 to the third power. So let's talk about in behavior. In order to do in behavior, we got to get all the leading x's with their exponents. So first one, -x squared times x, another x squared, but positive, and then x to the third. So for this, I'm going to take it one step at a time, just we have a negative. So -x squared times positive x squared, that would become -x to the fourth. And then I bring down the x to the third. So we got -x to the fourth times x to the third. That would be just -x to the seventh. Alright, now let's identify leading degree, which is 7, so it's odd. And then leading coefficient, we have a negative, so it's going to be negative. So odd degree and leading coefficient is negative. So we're going to identify our in behavior. So the right side, or I could do the left side again. So x approach to -infinity, so again the left side. When it's negative and it's odd, it's going to go towards infinity. Now, limit of the right side, so limit of f of x as x approach to infinity. So the right side is going to go towards negative infinity. So here's the left side, here's the right side. Now, zeros and multiplicity. Alright, I'm going to write up here because it might be a lot. So, first one is negative x squared equals 0. Well, I mean, you could divide by negative and it'd be x squared equals 0, and then you can square root it. So, let me show you. And then the square root of 0 is just 0, so x equals 0. And since it has an exponent of 2, so multiplicity, there's a dot, of 2. Multiplicity of 2. Now, our second one, x minus 1 equals 0. So, plus 1, plus 1. So, it's going to be x equal 1. And also has a 2 as an exponent. So, multiplicity of 2. And one more. So, x plus 2 equals 0. So minus 2 minus 2. So x equal negative 2 and has a 3 as the exponent. So multiplicity of 3. Now let's clarify on these zeros. So first one, second one, third one. So even multiplicity, so it's going to be here, tangent. The other one will also be tangent. Over here, it's going to cross the x-axis. Alright, so our left side, our right side, our zeros with their multiplicity. Alright, now we're going to transfer this information and then we can start graphing. So, I'm going to write limit of f of x to the left side, which is infinity, and then limit of f of x, the right side, also that will equal to negative infinity. Now, our zeros. So, I'm going to start with x equal negative 2, so 3, and then x equals 1 with a multiplicity of 2, and then x equal 0 with a multiplicity of 2. But gotta keep in mind, even multiplicity is going to be tangent, and odd it will cross. So at odd, it's going to cross. Even, so it's going to be tangent, and this one will also be tangent. Alright, so we got our information. Alright, we're going to start graphing. Again, it doesn't have to be a perfect graph as long as it's close to it and then hits all these points. So, here's the y-axis and x-axis. So, we got 0, and then we got 1, and then we got negative 2. So I'm skipping to make a wider graph. So here's negative 2. 1 and negative 2. So similar to the zeros we had before. Alright, so it says on the left side it's going to start up here, infinity, and then on the right side it's going to end at negative infinity, so down here. Hold on. Alright. So again, left side, infinity. And then right side, negative infinity. Alright. We got 3 points. 0, 1, and negative 2. So we see that at 0 and at 1 is tangent, but at negative 2 it crosses. So we can go down to negative 2, x equals negative 2. It crosses, so go down and then, so at 0 it's going to be tangent. So that means it's going to go and hit the x-axis, but not going to go through it. So go down. But it's also tangent at 1, so that means I got to go back up again. And then, again, I'm not going to cross it, so I'm just going to hit it at 1 and then go back down. And then go all the way over here. So that's our graph. So crosses at negative 2, x equals negative 2, tangent at 0, and then tangent at 1. So bend back up, go down, bend back up, and then go down again. So here's the graph. So again, I started up here. It went through negative 2, went down, and then it went back up. It's tangent at 0, went down, and then went back up. And then it gets tangent at 1, and then went back down. So my graph is similar to this. And again, it's not perfect, but it's close to it. It's similar. I hit all the points. My left side went to infinity. My right side went to negative infinity. So this graph will be good. So again, it doesn't have to be perfect. As long as you follow all the points, the end behaviors, the zeros, tangent, and crosses, then you will get full credit. Again, write this out for a partial credit, and then as long as you follow your information, you will get full credit.